Welcome back to Neural Intel. We're going to jump right in today with a breakdown of a really important piece, Andrej Karpathy's retrospective on the paradigm shifts that totally defined 2025 for large language models. We're going to get into the technical weeds here, but more importantly, we'll talk about what it all means for those of us who are actually trying to build and deploy these things.
Karpathy kicks things off with this quote, and it just nails it, doesn't it? This idea of jagged intelligence, this whiplash you get from seeing something brilliant one second and then just bafflingly dumb the next. That was the central puzzle of 2025, and as developers, it's the reality we have to design around every single day.
So here's our game plan. First, we're going to pop the hood and look at the new engine driving these models, a thing called RLVR. Then we'll get into the new mental model we need to actually understand them, this idea of ghosts, not animals. After that, we'll see how all this changes how we use them, from new UIs to vibe coding, and finally, we'll take a peek at what Karpathy thinks is just around the corner. Okay, let's kick things off with the biggest architectural change of the year, RLVR. And I want to be clear, this wasn't just some minor tweak. This was a completely new, fundamental stage in the training pipeline that pretty much changed everything.
Before 2025, the recipe for building a production-grade LLM was basically set in stone. We all knew the drill. You had your massive pre-training phase, followed by supervised fine-tuning, and then you'd align it with RLHF. That was the playbook.
And then 2025 happened. A massive fourth stage got bolted onto the end of the process, RLVR, which stands for Reinforcement Learning from Verifiable Rewards. This was way more than just another step. It was a whole new philosophy that completely rewrote how we thought about compute budgets and, ultimately, what these models were capable of.
So what is RLVR, really? Well, instead of just relying on fuzzy human feedback, you train the model for a really long time on tasks where the answer is objectively, verifiably right or wrong. Think solving math problems or passing unit tests in a coding puzzle. There's no gray area. And by doing this, you force the model to discover complex, multi-step problem-solving strategies on its own. It has to figure out what actually works to get that reward, and the result is something that looks an awful lot like reasoning.
All right, time for our neural signal check. Here's why RLVR is such a big deal for anyone actually deploying these things. First, it offers a huge bang for your buck, shifting compute away from pre-training into this powerful new reasoning phase. But second, and maybe even more important, it gives us a brand new scaling law. We now have a new knob to turn called thinking time, where we can trade more inference latency for a better, more capable answer. That's a massive new tool for balancing cost and performance in production.
Now, this new way of training, it doesn't just make the models more powerful, it makes them different. It creates a totally different kind of intelligence. And to work with it, we needed a whole new way to think about it. This is where Karpathy's analogy really clicks. He says we need to stop thinking of LLMs as animals that are evolving broad general skills for survival. Instead, we should think of them as ghosts that we summon to perform specific tasks. See, their intelligence isn't optimized for the physical world, it's optimized for imitating text and getting rewards in puzzles. That fundamental difference in their objective function creates a completely different kind of mind.
And this is what that ghost intelligence looks like in practice. It's jagged. An RLVR-trained model can be a superhuman genius at coding, just off the charts. And then, in the very next prompt, it can fail a simple, common-sense question a child could answer, or fall for a really basic jailbreak. This spiky, uneven, and kinda weird performance profile, that's the new normal you have to get used to.
So this brings up a huge, kind of uncomfortable question for the whole field. If benchmarks have verifiable answers, and RLVR is a technique for getting really good at verifiable tasks, what does it even mean to do well on a benchmark anymore? Karpathy points out that labs are essentially turning training on the test set into an art form by growing these capability jaggies to perfectly cover the benchmarks. It really makes you wonder if our yardsticks are still measuring what we think they're measuring.
Okay, so we've covered the new engine and the new mental model. Now let's talk about how this all changes the way we actually interact with these systems. Because, thankfully, we're finally starting to move beyond just a simple chat box. Karpathy highlights three major shifts that really took off. There's the emergence of a real app layer, with things like Cursor integrating AI directly into the code editor. Then you have the powerful local agent, like Claude Code. And finally, we're seeing the very first hints of a true visual GUI, like Nano Banana. These aren't just new features, they're entirely new ways of working with AI. Now, this move to local agents like Claude Code, it's a massive deal. For a long time, agents were stuck in a sandbox container in the cloud, with limited context. Now we have an AI running directly on your machine, with full, low-latency access to everything, your files, your development environment, even your secrets. And in this era of jagged, uneven AI, Karpathy argues this is the most practical way forward for now.
Neural signal check time. Let's talk enterprise deployment. This right here is a game changer. For any serious company, the idea of sending their proprietary source code and sensitive data to a third-party API is a complete non-starter. It's a security nightmare. Local agents flip the script entirely by bringing the model to the data. This isn't just a feature, it's the unblocker that solves the single biggest barrier to enterprise adoption, period.
All right, next up is a really cool concept that Karpathy calls vibe coding. This is all about lowering the barrier to entry and fundamentally changing what it means to create software.
In 2025, we crossed a really interesting threshold where you could build surprisingly complex and useful programs just by describing what you want in English. Karpathy himself used it to write a custom tokenizer in Rust, a language he didn't really know. Just think about the implications of that. Code becomes so cheap to produce that it becomes disposable. You can just vibe out a quick script for a single task and then throw it away. That completely changes how we approach building things.
Okay, last section. Let's look to the future. If the underlying models have changed so drastically, it's only a matter of time before the way we interact with them has to evolve too.
Here's another fantastic analogy from Karpathy. Chat is the command line of our era. It makes perfect sense when you think about it. Text is the native, raw format for the LLM, just like the command line was for early operating systems. But it's not the native format for people. We don't think in text streams. We're visual creatures. And that sets the stage for the next great leap in user interfaces.
So what will the GUI of the LLM era look like? Well, early multimodal models like NanoBanana are giving us a glimpse. And the key technical bit here isn't just that it can make an image, it's the joint capability fusion. The model's weights don't just understand text and images as separate things, they're fused. It understands the deep relationships between them. That fusion is the foundational tech for a true LLM GUI, one that can generate rich visual outputs like infographics or slides as a native format.
And that quote really sums up the paradox of 2025. On the one hand, progress is moving at a breakneck, almost unbelievable speed. But on the other hand, the conceptual space feels so wide open. It feels like we've only just begun to scratch the surface of what's possible.
So I'll leave you with this question to chew on. 2025 was clearly the year of RLVR and local agents. Those were the big paradigm shifts. So what's next? What's the next fundamental breakthrough waiting just over the horizon that's going to flip the whole table all over again?
And that's our look at Karpathy's 2025 in review. To stay on top of the technical deep dives that actually matter in AI and machine learning, make sure you're subscribed to Neural Intel on Apple Podcasts, Spotify, or wherever you listen. And check out our other explainers over at neuralintel.org. Thanks for tuning in.